So now that we learned what an aromatic compound is and what must be satisfied for a compound to be considered aromatic, let's take a look at the following 6 molecules and determine which one is aromatic and which one is not. And let's begin by looking at the 4 criteria that must be satisfied. So, for any compound or molecule to actually be aromatic, it has to be cyclical, it has to be planar, it has to be fully conjugated, and it has to have the correct number of pi electrons. So it has to satisfy Huckel's rule. So 4n plus 2, where n is any number that begins with 0 and increases by increments of 1. So let's begin with molecule A. So in molecule A, I've labeled carbon 1, carbon 2, and carbon 3. So the question is the molecule cyclic? In fact, the molecule is cyclic. Not only that, it's planar. All the carbons are found along one plane and it is fully conjugated. So if we draw our molecular orbital diagram for this particular molecule, we see that the molecule is in fact fully conjugated. So basically our blue lobes are found like so, and our green lobes are found below our plane. So we have green orbital here, green lobe here, and green lobe here. So we have the 2 electrons here, we have the 2 electrons here, and all these electrons are basically delocalized around these 3 orbits. Now, the question is or does this molecule actually contain the correct number of electrons? So we have 2 electrons found in the pi bond between carbon 1 and carbon 2. And we also have 2 electrons found on this 3rd carbon here. So we have a total of 2 plus 2 or 4 electrons. So the question is, can 4 ever equal to 4n plus 2, where n is any number that begins with 0, can be 1, can be 2, can be 3, and so forth. So if we choose n equals 0, our value for the pi number of electrons is 2. If we choose 1 to be n, then 4 plus 2 is equal to 6. In fact, we can never get a value that is equal to 4. And because our molecule doesn't satisfy rule number 4, it doesn't have the right number of electrons, that molecule is not aromatic. So molecule A is not aromatic because it doesn't satisfy Huckel's rule. So we can also check by using the Frost circle. So if we draw the Frost circle for molecule A, we see that 2 electrons are found in the lower in energy and stable bonding pi molecular orbital, but the other 2 electrons are found in the higher in energy unstable anti-bonding pi molecular orbitals. Now, let's move on to molecule B. So molecule B is very similar to molecule A, except there is an important difference. So even though molecule B is cyclical, fully conjugated, and planar, it doesn't have the 2 electrons that molecule A has. And that means it has 2 less electrons. And in fact, because of this, it will satisfy the last rule. It satisfies Huckel's rule because if we let n is equal to 0, then 4 multiplied by n, which is 0, plus 2, does in fact equal to 2 pi electrons in our molecule. So the molecule is fully conjugated, it is planar, and it is cyclical. And not only that, but it also obeys our Huckel's rule. So let's draw the 3-dimensional orbital diagram for this particular molecule. So we have our two orbitals here, 2 lobes here, we have the 1 lobe here, and we have the green lobes, which basically have the negative sign on the bottom below our plane. And this one has a positive charge. So it's basically an open 2p orbital. And that means electrons can basically move along all these 3 orbitals. So we have electrons that is delocalized among all these 3 orbitals and these lobes here. So basically everything here is satisfied, and molecule B is in fact aromatic. Now, let's move on to molecule C. So molecule C is a cyclical molecule. It is planar and it is conjugated in the sense that this boron contains an empty 2p orbital, an empty orbital that basically allows these electrons to interact with this orbital. So we see that all these atoms in our ring structure are conjugated. The question is, what is the total number of pi electrons? So just like in molecule A, molecule C has 4 pi electrons, and we know from this argument that this rule will never give us 4 pi electrons, and so this molecule C, for the same reason as A, is not aromatic. This is not aromatic. This is not aromatic. This is aromatic. Now let's move on to D. So D in a way is slightly complicated in the sense that it looks strange. So we don't actually have any carbons. Instead, we have nitrogen atoms and we have our borons. So, but really, we can treat these atoms as if they were carbon in the sense that any lone pair of electrons still counts as the pi electrons, and any bond, any double bond between, let's say, nitrogen and boron also counts as being a pi system. So basically, it contains electrons in our pi bond. So basically we have 1, 2, 3. So we have 3 pairs of electrons. So we have a total of 6 pi electrons that can go into the pi molecular orbital system. Now that basically means that rule number 4 is satisfied. So we have 4n plus 2 will equal to 6 when our n is equal to 1. So the question is it cyclical? Well, basically, it's a 6-member ring, so it is cyclical, it is planar, but is it fully conjugated? So let's draw our molecule. Let's draw the 3-dimensional orbital diagram for our molecule. So it looks something like this. So we have boron, nitrogen, boron. This is nitrogen. This is boron. This is nitrogen, this is boron. So we have our H atom here, we have our H atom here, the H atom there, we have our lobe 2 electrons, our lobe 2 electrons, our lobe 2 electrons, and each one of these borons also contains an empty 2p orbital. So in fact, we see that there is resonance stabilization, and our molecule is in fact fully conjugated because there is this interaction between our lobes, between our atomic orbitals. So we see that everything is satisfied, and molecule D is in fact an aromatic compound. So this is, yes, it's aromatic. Now, what about molecule E? So right off the bat, we can say that molecule E is not aromatic. The question is why? Well, the simple answer is as follows. If the pi bonds are not entirely found inside the ring structure, the molecule is not aromatic. And because this pi bond is not inside the ring structure, this molecule is not aromatic. Now, finally, let's look at the last molecule, molecule F. So molecule F is in fact cyclical. It is planar and fully conjugated, but the molecule F does not actually obey the last rule. So we have 2, 4, 6, 8 pi electrons, and this will never equal to 4n plus 2, where n is our value of 0, 1, 2, 3, and 4, and so forth. So if n is equal to 0, this is 2. If n is equal to 1, this is 6. If n is equal to 2, this is 10. So we skip 8 in the same way that we skip 4. So neither 4 nor 8 is the correct number of pi electrons. And if we use the Frost method for this particular molecule, we will see in the same way that in this case does not satisfy our aromatic compound. So this molecule is not aromatic. So we see that only 2 of these 6 compounds is two of these is aromatic. So molecule A is not aromatic, molecule C is not, molecule E and F are not, molecule D and B, however, are both aromatic because they satisfy all these 4 criteria.